In this lesson, we're looking at arithmetic sequences. We're going to learn how to identify this type of sequence, as well as write a rule for an arithmetic sequence, and find the nth term or a certain term in an arithmetic sequence. So let's go ahead and get started. What exactly is an arithmetic sequence? Well, it is a sequence where the difference between any two consecutive terms is constant. So basically you're adding or subtracting to get the next term, or you're adding or subtracting the same number to get the next term. Well, what is a common difference? A common difference is the numerical difference between any two consecutive terms, and this difference is denoted by the letter D in the arithmetic sequence formula. So now let's take a look at these 6 problems here. We want to determine whether these sequences are arithmetic sequences, and if it is, we want to identify the common difference. So we're looking at number 1. So we notice from 1 to 5 we're adding 4, 5 to 9 adding 4, 9 to 13 we're adding 4. So since we're adding the same number, it is an arithmetic sequence, and our common difference is 4 because we're adding 4. Looking at number 2, 1 to 3 we're adding 2, 3 to 5 we're adding 2, but 5 to 8 we're adding 3. So we're not adding the same number, and so this would not be an arithmetic sequence. Let's take a look at number 3. From 8 to 6 we're subtracting 2, 6 to 4 minus 2, 4 to 2 we're subtracting 2. So subtracting the same number. So yes, that would be an arithmetic sequence, and our common difference is -2 because we're subtracting 2. Let's take a look at number 4. From -5 to -8, we're subtracting 3. From -8 to -11, we're subtracting 3. And -11 to -14, we're also subtracting 3. So again, since we are subtracting the same number, it is an arithmetic sequence, and our common difference is -3. Number 5. From 5 to 10, we're adding 5. From 10 to 20, we're adding 10. So we can actually stop here because we're not adding the same number. So we can just go ahead and say that no, this is not an arithmetic sequence. And our last one here, number 6, from 7 to 6, subtracting 1, 6 to 5, minus 1, 5 to 4, we're subtracting 1. And so yes, this is an arithmetic sequence, and our common difference is -1. Looking at these 3 problems that are arithmetic sequences, we want to find the next 3 terms. So the first thing we want to do is figure out what the common difference is and follow that pattern. So the first one here, 9 to 13, we're adding 4, 13 to 17, adding 4, and 17 to 21, so we're adding 4. So our next 3 terms would be 25, 29, and 33 because we're simply adding 4 to the previous term. Next, from 5 to 2, subtracting 3, 2 to -1, subtracting 3, and again we're subtracting 3. So our next 3 terms are -7, -10, and 13 because again we're just subtracting 3 from our previous term. The last one here, from -8 to -2, we're adding 6. -2 to +4, we're adding 6, and from 4 to 10, we're adding 6. And so we just want to add 6 to each term. So our next 3 terms are 16, 22, and 28. So now we want to look at arithmetic sequence formulas. And the first type of formula we have is called the recursive formula. The recursive formula gives the value of a specific term based on a previous term. So the form that we use is a sub n equals a sub n minus 1 plus d, and everything would be the same when you're writing this form right here. So you would write a sub n and a sub n minus 1. The only added piece is that you would substitute your common difference in there. And so as an example, we have 4, 8, 12, 16, 20. And so we can see that we're adding 4, and so our recursive formula would just be a sub n equals a sub n minus 1 plus 4. So that is the only thing that we have to change there. Now, if we're looking at the explicit formula, each term in a sequence can be calculated directly without knowing the previous term's value. And this also gives the value of a specific term based on the position. So normally if you want to find a certain term in a sequence, you're going to use the explicit formula, which is what we're going to be using for a majority of the lesson, because we can find the nth term, meaning any term that we're asked to find, using that formula or the explicit formula. So this is the explicit formula. You have A sub n equals A sub 1 plus n minus 1 times d. Of course, we know that d is our common difference. What does everything else mean? Well, A sub n is just that nth term, and so whatever term that we're looking for, that is what we will plug in for n. A sub 1 would be our first term. N is the number of terms, and d, of course, would be our common difference. Some other ways that you may see this formula is this way, where you just have, instead of having the d, the difference in the behind the n minus 1, you may see it in front of n minus 1. And you may also see it this way, where you have your a sub 1 or your first term at the end there. And so these formulas all are explicit formulas for an arithmetic sequence, and so it can be written differently, but it's going to give you the same result. Looking at these two examples, we want to write a rule for the nth term, then find a sub 19 or the 19th term. And so I'm going to use this formula here where my common difference is first. But once again, you could use any of those forms for the explicit formula, because for the explicit formula, we want to find a specific term. And so I'm using this formula here. So first thing we want to do is identify our common difference. And so from 7 to 13, adding 6, 13 and 19, adding 6. And so our common difference is 6. And then we want to identify our first term. So our a sub 1 is 7. So the only thing that you need to write in explicit form is your first term and the common difference. So now I'm simply going to fill in. So I'm just rewriting the formula here and fill in my given information. So I want to write a rule. So my common difference is 6. And I leave that n minus 1. And a sub 1 is 7. So you may see it written this way, but if you're asked to simplify it a little more, we're just going to do the distributive property and simplify it a little more. So that would be 6n. Combining my like terms, that would be plus 1. So we could actually write it this way, or you may see it this way. So just depending on what you're asked, if you're taking a multiple choice question test, both of these would be correct, but the last one here is the simplest form here. So when in doubt, I would just write it in simplest form. Now I want to find a sub 19 or the 19th term. So I simply plug in 19 for n. 6 times 19 plus 1, that is 115. And so my rule is a sub n equals 6n plus 1, and then my 19th term is 115. Let's take a look at this next one here. Common difference is subtracting 4. So minus 4. A sub 1 is 30, my first term. And then plugging it into my formula, I'm not going to rewrite the formula this time. So my common difference is negative 4. Bringing down that n minus 1 plus 30, which is my first term. And so I could actually leave it like this, but when in doubt, simplify it. So distributive property, negative 4n, negative 4 times negative 1 is positive 4, plus 30, negative 4n, 4 plus 30 is 34. So that's plus 34, and That is my form. I want to find the 19th term, so just plugging in 19 for n, I get negative 42. So I have written a rule for each one of these problems, and I have found the 19th term. So for these 4 problems, I would like for you to try them on your own, write a rule for the nth term, as well as find the 19th term. So go ahead and pause the video and try these problems on your own. Okay, so I have the rules here boxed in, and they're also in red. So here. So the first one, a sub n equals 3n minus 14. My 19th term is 43. So just go ahead and check your work. And of course, if you're asked to find any other term, like if you wanted to find the 11th term, you would just simply plug in 11 for n. But in this case, we were finding the 19th term, so just pause the video and check your answers. Now we have an application problem or a word problem. So let's look at this problem here. It says you visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second. I'm going to circle the word first. 48 feet the next second, and 80 feet the third second, and so on. We want to write a formula to represent this sequence. And so my terms are 16, 48, and 80. Let's figure out the common difference. Common difference from 16 to 48. What is happening there? I am adding 32. And 48 to 80, we're adding 32. So my common difference is 32. My a sub 1, or my first term, is 16. So let's just plug that in. A sub n equals 32 times n minus 1 plus 16. And if I want to simplify that, doing a distributive property, plus 16, combining like terms, negative 32 plus 16 is negative 16. So this is my formula. I'm going to say both. And then it says, how far would the penny have traveled after 6 seconds? So 6 would be n, so I basically want to find the 6th term. So a sub 6 is equal to 32 times 6 minus 16. And that gives me 176. And it says, how far will it have traveled? This is in feet, so 176 feet. We have this application problem here that I would like for you to try. It says the total bank loan for Tara's new car is $15,265. The bank automatically withdraws $295.80 each month to pay off the car. And so pay attention to the word withdraws and go ahead and pause the video and try this problem on your own. All right, so let's check your answers here. Hopefully you got them correct. Our common difference is negative $295.80. Why is it negative? Because Tara is withdrawing $295. The initial value, or the first term, is the $15,265 because that is the original bank loan. And so our formula is here, so hopefully you got that correct. And then it says what will be the balance of the loan after 2 years. We plug in 24 instead of 2 because it says each month. And so the problem was given or the original problem was talking about months. And so since it's referring to months, we got 12 months in a year. 12 times 2 is 24. And so we plug in 24 for our number or term there. So you should have gotten 8,461. So hopefully you got it correct. If not, pause the video. If you don't have a need to pause, if you understand it, that is wonderful. So we have reached the end of our lesson, and I really want to thank you for learning with me.